JSON is a popular Java-based library for working with JSON data. The library is developed and maintained by Faster XML and provides a set of powerful tools for parsing, generating, and manipulating JSON data in Java applications. Some of the key features of JSON include data binding. This allows to map JSON data to Java objects and vice versa using annotations or configuration files. Annotations. JSON provides a variety of annotations that you can use to control how JSON data is serialized and deserialized. Tree Model API. This provides a convenient way to work with JSON data in a hierarchical tree structure similar to the DOM in XML. Streaming API. This allows to process large JSON documents efficiently and quickly, without having to load the entire document into memory at once. Customization. JSON is highly customizable, with a wide range of configuration options that allow you to fine-tune its behavior to suit your specific needs. Let's look deeper on these features. Data binding is the process of connecting data from a data source, such as a Java object or JSON string, to the data target, such as a JSON node or JSON parser. Here we have two cases. Serialization. The data source is Java object, and the target source is JSON representation of JSON. The purpose of data binding is to reduce the amount of code needed to synchronize the data between the data source and the data target. Annotations help to control the serialization and deserialization of Java objects to and from JSON. Here are some of the most commonly used JSON annotations. JSON property. This annotation is used to map a Java class field to a specific JSON property name. In this example, we receive JSON key as brand_name and our Java field in camel notation, brand name. This means that when we receive brand_name from JSON, we will map it to brand name field with camel notation. JSON ignore. This annotation is used to ignore a Java class field during serialization and deserialization, and vice versa. During serialization, the Java object with field color, we will not receive it in our JSON. JSON format. This annotation is used to specify the format of a class field that represents a date or time value. You can visit GitHub repository of JSON annotations for more information. The Tree Model API is one of the features of JSON library that provides a way to represent a JSON document as an in-memory tree structure, where each node in the tree corresponds to an element in the JSON document. Let's say we have a Java object, Pojo for example, that contains some fields. We can serialize this object to tree like JSON node that has binded its element from Pojo fields. And vice versa. If we have JSON node with some elements, we can deserialize it to Java object with same elements as object fields. You can learn more from JSON data bind repository on GitHub. In this example, we create an object mapper to work with JSON data. Then we use readTree method to parse JSON document or JSON string in our case to create a JSON node object, which represents the root node of the tree structure. This is how root node object looks like. We have two children, name that represents a key of the JSON and Joe that represents a value of name key. The same with age. Age represents the key of JSON and 50 represents a value of age key. This is how a print looks like. JSON Streaming API is a powerful feature that allows to process large JSON documents or strings efficiently and quickly without loading the entire document or string into memory. Instead, the library reads and processes the JSON data incrementally as it's received, which can significantly improve the performance and memory usage of your application. For more information, please visit JSON core repository in GitHub. To use the streaming API, you typically start by creating a JSON parser object, which provides a way to read JSON data from a stream or a file. You can then use the parser methods to iterate over the elements of the JSON document, such as the start and end of objects and arrays, and the keys and values of object properties. In this example, we create JSON parser object to read JSON string, and then use a while loop to iterate over the elements of the document. For each element, we check its type using getCurrentToken method, and then read its value using the appropriate method, such as getText for strings. This is how JSON looks like in the parser object. This is how the print looks like. JSON provides powerful features for customizing how JSON data is serialized and deserialized. Serialization and deserialization of specific types. If you have a custom data type that needs to be serialized to a JSON string in a specific way, you can write a custom serializer for that type. Naming strategies. Mapping Java field names to custom JSON property names. Ignoring properties. Ignore certain properties during serialization or deserialization. Configuring date and time formats. Specify a custom format or time zone to use when serializing or deserializing date and time objects. Configuring null handling. Configure JSON to ignore null values, include them as null in the JSON output, or throw an exception if a null value is encountered. In summary, JSON is a popular Java library for working with JSON data. It provides a wide range of features for converting Java objects to JSON and vice versa, including streaming, data binding, tree model, JSON schema support.